Well, as much as I hate to start without people, I kind of just want to rip this Band-Aid off, you know?
If I send you this, can you put it on the server?
All right, so we only have 2 days to review for your semester exam. Hi, Charlie. Exam review's right back there. Y'all take your exam on Tuesday, and then I don't see you Monday. So we really just have today and Thursday to work on it. If you complete your semester exam review, you will get the square root curve on your exam grade. Okay. So if you don't know what the square root curve is, think like a 36. What's the square root of 36? 6 times 10 is a 60. So a 36 would go to a 60. So it's a pretty nice curve. If you get, let's say, 64, what's the square root of 64? 80. Then it would go to an 80. So it's a pretty generous curve to reward you for doing your semester exam review. And so my hope is that it'll also help you get a better grade on it in the first place. So the first topic in your review is vectors. So we're just going to kind of do like examples from half of it today. You'll finish it. We'll do the second half next time, and then y'all will finish it on your own. So let's do number 1. Okay, if you're asked to draw a vector, okay, you should know that a vector is an arrow, and while you can start vectors wherever you want, okay, usually I would start it at the origin. Then if I'm doing negative 5, 12, I'm going to go 1, 2, 3, 4, 5. Then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Remember that your vector should point in the direction that you mapped it. So if you started it at the origin, okay, then that one would go to the left and up. Okay. Then from there, you're asked to find the magnitude. You will have a cheat sheet, or not cheat, a formula chart, whatever you want to say, that'll have all these formulas on it. Magnitude is the square root formula. And then you do 5 squared plus 12 squared. Okay, and then I'm re-inventorying my calculators, sadly. So I'm going to ask you to work today on Desmos, but by next time you'll have them back. I just have to track. A lot of my AP kits had to check them out. I have to make sure I got them all back. So you can do this in Desmos, but 5 squared plus 12 squared. That gives me 169. And then remember, if I can square root 169, I'm going to do it. But if it comes out to a decimal, I'm going to leave it. So the square root of 169 happens to be exactly 13. Remember that that is how long the arrow is. Okay. For direction, you're going to do tan theta equals y over x. Remember, no negatives in this formula either. So it'd be 12 over 5. And then remember, your mode on this has to be degrees or it's going to come out wrong, which you should still be able to pick on Desmos, but I can help you with that if you need it. Okay, then from there, you're going to hit second tan, 12 over 5. Okay, that comes out to 67.3 degrees. We'll just round that to 67. Now, don't put that in your direction point. Remember, that's the reference angle. For direction, you have to use the little chart. So remember, in quad 1, your theta stays the same. 180 minus, 180 plus, and 360 minus. So this is step 1, and then this is step 2. So if I'm doing this vector, I can see it ended up in which formula? The 180 minus, very good. So then I do 180 minus the 67, and that will be my final answer for right here. So 180 minus 67, that gives me 113. Okay. All right. Okay, we're gonna skip down now to number 4. Okay, so if you'll take a look at number 4. Okay, you have 2 vectors. Okay, notice that they're in IJ form, but it really doesn't matter. It's the same thing. Okay, and it asks you to find 2u minus 3v. So I'm gonna put 2 blank minus 3 blank. And then in those spots, I'm going to put vector u and vector v. So my u is going to go here. My v is going to go here. My u is a 7i plus j. And my v is an 8i minus 3j. Okay, then remember, you're going to follow PEMDAS on this. The M stands for multiply. So any outside numbers, you're going to times those in first. Then you'll add or subtract the like pieces. So for my 2, go ahead and times that in. 2 times 7i is now a 14i. 2 times j is now a 2j. And then what am I timesing into the second vector? Not just a 3, but a -3. Very good. So -3 times 8i is a -24i. -3 times -3 is then a +9j. Okay, and then don't be freaked out on the exam. The i's and j's have the little vector thing on top. I just used a regular I and j in Microsoft Word. Okay, but they'll show up like this on your exam. Okay, then from there, you're adding the like parts together. So my 2j and my 9j give me 11j's. And then my 14i and my -24i give me a -10i. Okay. You should also be able to convert this back into a regular vector. Okay, but remember, these 2 vectors are the exact same thing. It's just notation. You're either in IJ form or you're in, this is called component vector, where you have the little pointy guys. Anderson, you need pencil money? Okay. All right, go ahead and turn the page. So we covered vectors. We also covered polars. So let's run through a little bit off this second page here. Okay, if I'm asked to put point P, the coordinates, remember that for polar, it's the ring and then the theta. So I see that point P is right here. The first thing that I'm going to do is count how many rings out from the center it is. So it's 1, 2, 3. Then it would be 3, comma. Then my second thing is supposed to be my theta. You can see your unit circles measured in radians. So what would I call that angle? What would that direction be? 30, but let's do it in radians. pi6, good. Okay, then it asks you to do it a second way. And so the way that I'd like you to do the second way is with a -r. So what I mean by that is I'm going to go 3 rings towards pi6. But if I wanted to go -3 rings, do you remember that you'd pick 7 pi6? And then instead of counting 3 rings towards it, you'd count 3 rings away. So the second way that you could name that point is -3 and then 7 pi6. Okay, where essentially if you're using a negative ring, you're going across to the opposite quadrant of the circle. Okay, then you're asked to do the same thing for 2 more points. And then you're asked to plot a couple of points here, which I feel like hopefully you could do. Okay, go down to your next section. You're asked to convert into x, y. Your formulas for these, if you don't remember, we're going to do, we'll do the middle one. We'll do B. Okay, your formulas are x equals r cosine theta and y equals r sine theta. Okay, then remember to get the sine and the cosine, this is the one where you'd use the unit circle. So I'm going to type in write in my answers here. This is my R, this is my theta. So my X is going to be a 7 cosine 3 pi fourths. My Y is going to be a 7 sine 3 pi fourths. And then, like I said, to find these numbers, that's where you're going to have to use the unit circle. Okay. Which there's one on Schoology for you to use in case you lost yours, but I have one right here that I'll just put up here. So we're looking for 3 pi fourths. 3 pi fourths is right here. And then remember, I'm going to take this ordered pair. The X is the cosine, the Y is the sine. So my X is a negative root 2 over 2. And then your Y is almost the same, it's just not negative. Okay. Then from here, what you would normally do is whatever this number is, you would divide it by 2. Can 7 divide evenly by 2 though? Yes, no? No, so in this case, I would just leave it as a fraction. Okay, if you want to divide the 7 by 2 and put it 3.5, that's fine. Okay, but I'm just gonna leave it like this. That's my X, and then this is my Y. And that would be your answer. Okay? But normally you would divide these. The problem is that for us, the 7 just can't fully divide by the 2. So I'd just leave it as a fraction. Okay? All right, the other thing you'll be expected to know how to do is to go the opposite direction. So for that, we're going to do letter B right down the middle. Okay, the first thing that you're going to do is find the R. So this is an X comma Y. So to turn that into an R, we're going to find the magnitude. Okay, remember for this, you're going to leave it as a square root unless it comes out perfect. So if I type 5 squared plus 7 squared into my calculator, that gives me 74. And then 74 cannot square root evenly. So I'm just going to leave it like that. After I find my R, I need to find my theta. And remember, the steps are the same as they were for vectors. So you're going to start with your tan theta is y over x. You're going to find that answer and then plug into your direction chart. So second tan, 7 over 5, gives me 54 degrees. But then I have to think about which quadrant this ordered pair would end up in. So let me put my little formula up here. I'm looking for -5, -7. So I would go to the left 5 and then down 7. That would put me in 180 plus. So then you do 180 plus 54, which would be how much? And then remember, you just put these guys together in an ordered pair, just like you did on that test. So it'd be root 74, comma 234. Okay. But you will have a formula chart with those different formulas on it, so you won't have to memorize them. Okay. All right, go ahead and we'll maybe do another page or two and just kind of see how it goes. So on the unit circle, okay, like I said, you'll have a copy of it. Let's just do these two right here. Let's do these two. So if I'm looking for tan, do you remember how we find tan on the unit circle? Yes, good job, Jared. Okay, tan is y over x. So I'm going to have to find pi 6 on the circle. Then I'm going to pull the y, pull the x, and then divide them. So let me put my circle up here. Okay, I see that pi 6 is right here, which means root 3 over 2, comma 1/2 is my guy. But remember, it's y over x. So my y is a 1/2 over my x is a √3/2. And then remember, if you're trying to divide two fractions, that's where you would keep change flip. So your 1/2 is your keep. You change it to a multiply, and then you flip the √3/2 to a 2/√3. What's going to happen with those twos? One of them's on top, one of them's on bottom, then cancel them out. So I have 1/√3 as my final answer. Why will I not see that answer choice on an exam?
The square root.
Square root can't stay on the bottom, that's right. So you'll do another √3 to fix it. That gives you 1√3/3. Okay, you do not have to write the 1 in that front spot if you don't want to. It is fine if you don't. All right, for CSC, do you remember which one we flipped? It's sign flipped. Very good. And remember that sign is which one? The y value. Very good. So secant is the x flipped. CSC or cosecant is the y flipped. So we're going to find 4π3 on the circle. So 4π3 is here. And then we want the y value, and then we're going to flip it. So instead of negative √3/2, it's going to be negative 2/√3. And then we notice that same thing as last time, you can't leave the square root on the bottom. So it'd be √3/3. Remember though that if it's a sine or a secant, you're just picking the x or the y. So the other ones do have different formulas, but they're all on your chart to remind you which one's which. All right, let's do one of these off the bottom row. Let's do number 11. Okay, what do you think we should do first on number 11? We're trying to get the theta by itself. Divide the 4 is a great start. So I have sine squared theta 3/4. Okay, next we want to get rid of that squared. How do we do it? Square root. And when you square root a fraction, remember you want to do the top and the bottom separate. The reason why is sometimes you can square root part of the fraction, but not the whole thing. So for example, on this one, these guys are going to cross out, so I'll have sine equals. Can I square root 3? Not evenly, right? Can I square root 4 though? What's the square root of 4? 2. Okay, also don't forget then your plus or minus. Hey, what's on?
Oh, wait, whenever, is it gonna be like, for example, is that the borrow and maybe like?
The band?
Yeah,
You can burn them.
okay, doing the test?
Are you taking the apes?
Yeah.
Is it in the afternoon?
Yeah.
I can just plug it in, you can come get it later.
Okay, thank you so
I
much.
don't know if it was probably charged for part of it, but maybe not the whole thing.
Also,
So,
do you have like, I think the
yes.
You do?
What's wrong with you? Do you have a headache?
Yeah, she has a good,
You're sure you're not allergic?
yeah, probably.
So look
Sorry.
on here, that's okay. On my circle, I want you to look for where the y value is either of these numbers. Now, keep in mind that if it's a plus or minus, you're looking for 4 spots. Okay? So there's my circle. See if you can find it.
I think I had literal honey.
I ate a honey on a spicy biscuit from.
Weird.
No, and then I touched my face on.
Wow, I took your life mission. I did.
These are coffee.
Oh, this is so my
You never know
mom.
if you'll be.
Aw.
Do you want to? Okay.
Thank you so much.
You're welcome.
Later to come pick it up.
Good luck.
Thank you.
And don't forget to bring your cactus.
Oh yeah, already good. Thank you.
Okay, bye.
Okay, bye.
So did you find it? So we have a √3/2 here and here. Remember, they have to be the y's because it's a sign. So I'd want π3 and 2π3. And then on the bottom, I don't know if you remember this from when we covered it, but they're always the same type. So if these are the thirds, then the other ones are 4 pi thirds and 5 pi thirds. Okay. But you'll only get 4 answer choices if you have a plus or minus. All right. I think we'll just do one more. Let's do number 15. That's a good place to stop. So number 15 says our theta is in quadrant 3. This is all the way back to January. So it goes 1, 2, 3, 4, if you're not sure. So I want you to draw me a line going into quadrant 3. Okay, it doesn't have to look perfect, but you're going to start it at the origin, and then you're just going to come out this way. When I create my triangle, I know this is old, but do you remember which axis I have to connect it back to? Is it X or Y?
X.
X, good. Remember, you never go back to your X in real life, okay? But for this, you can go back. Okay? Then remember, your theta always goes in the middle. And then if your theta is that central angle, you should be able to identify your adjacent, your opposite, and your hypotenuse. The hypotenuse is the slanty side. The adjacent is the one that's touching the theta, which means that your opposite is over here. Okay, then from there, if they're telling you, that your sine is a negative 2/3, which sides does that give you? Do you remember SOHCAHTOA? Opposite and the hypotenuse. Very good. So sine gives you SO, cosine is CA, tangent is OA. And then remember, if you flip those 3 guys, you get their 3 partners. So this will be H over O, H over A, and A over O. So when I label on my circle, I see that my sine is negative 2/3, then my O is a 2, my H is a 3. Okay, then I noticed it was a negative. Where should I put the negative? If this is a down 2, then does it make sense that's my negative? How can I find this third side? A squared plus B squared equals C squared. So to find that side, I'm going to do A squared plus 2 squared is 3 squared. That's A squared plus 2 squared is a 4. 3 squared is a 9. What's my next step? Cancel out the plus 4. We need to minus it. 9 minus 4 gives me 5. Which means that A is the square root of 5, which if I could do it, I would, but square root 5 is not a perfect square root, so I'm just going to leave it just like that. So this is going to be the square root of 5. And then from there, I can fill in my SOHCAHTOA. So is O over H. Is root 5 over 3. And then OA is negative 2 over root 5. Then remember, before you fix any square roots on the bottom, you want to do the 3 flips first. So if that's a negative 3 over 2, that's, oh, actually, hold on, we made one mistake. Which direction is this for the root 5? To the left, then that one should be negative. So remember that you have to think about these have positives and negatives. If I'm going to the left root 5 and then down 2, these need to both be negative. So go ahead and put that into your answers that had a root 5. So now when I flip it, negative 2 over root 3 is a negative 3 over 2. My negative root 5 over 3 is now a negative 3 over root 5. And then my negative 2 over negative root 5 is now a negative root 5 over a negative 2. And then what do I do with these if they have double negatives? they're gonna just cross out. So this will be positive root 5 over 2. This one's good. This one's good. This one's good. Why did I not box the other two? Roots on the bottom have to be fixed. So I'll repeat my root. Now it's a -3 root 5 over a regular 5. And then -2 root 5, positive 2 root 5 over a regular 5. Okay. And then you should be able to use that example to work 15 and 14. So I would say a really good stopping place for you today would be try to get to number 16. Okay, you still have an hour, so that's plenty of time. If you need any help, please ask me, and you can do it. Okay? And then maybe I'll just give you your formula chart now, so you don't have to dig up an old unit circle. Will you just try not to lose it?